Welcome to the talk that has the title, The Need for Speed. What is GraalVM? Who of you have already heard about GraalVM? Please raise your hand. Okay, I don't have that many umbrellas or Spoina entries, so sorry, not this time. Did you like it? Who liked GraalVM? Who tried it and liked it? Okay, less people. You might want to have some questions after the talk. So if you won't have any question about whatever I'm talking about at the moment, please raise your hand and interrupt me so that I can explain or answer your question. If you have some broader question or you want to learn something more about GraalVM itself, just please ask after the presentation. Okay, so a few words about me. Just a few words. I'm working at Spartas. That's the company based in Gdańsk. We develop Jira plugins and Atlassian Stack. By education, I'm a molecular biologist. But when I went out of the university, I became a software developer. Actually, I was developing software since I was something like 12 years old or so. So I was always hooked on computers, and nowadays when I have any bit of free time, because you know work, family life, and this stuff, whenever I have a couple of minutes of free time, I either prepare talks for conferences or brew a beer at home. Okay, so the presentation plan. There are three things that I want to talk about today. The first one is the motivation for GraalVM, right? So why do we have something like GraalVM? Why did Oracle come up with something like that? And I will discuss the current status of JVM, Java Virtual Machine, the Oracle Java Virtual Machine or the OpenJDK Java Virtual Machine. Then I will talk about what is GraalVM, what are the parts that it consists of, and what are the special techniques that it uses to improve the situation. And then I will try to explain if it's even worth your time. Most of you have heard about it. Maybe you are interested in if you should research it more. Then I will try to answer that question in the last part of the talk. Okay, so let's talk about the current status of the JVM. And I need to make one disclaimer here. There will be a couple of controversial statements during this presentation. It's not for the sake of controversy itself, it's just to discuss the thing. So please don't be offended if you find a controversial statement in this talk. I've got two controversies to start with. One is Java is slow, the other one is Java is fast. So when Java was released, the first version of JDK, Java 1.0, 1.1, you probably remember that people were telling that this is slow, this is not usable, there is no way you can use it for software, right? And then some people say, most people think today that Java is fast because, well, we've got optimizations and all that stuff, and Java is pretty much has native performance. You could write C++ code and it wouldn't be that much faster, right? So, which one it is? Is Java slow or is it fast? Who thinks Java is slow? Oh, only one person. Okay, one more. Who thinks Java is fast? More. And those who didn't raise their hands, what do you think? It's neither slow or fast, okay. Well, my answer to those two controversies is, of course, it depends. It depends on what do you mean by it is slow, it is fast. Because, of course, one thing about JVM, it's in its core, this is a stack-based virtual machine interpreting bytecodes, right? So it has a jump table for every bytecode, and it executes code when it reads a bytecode. It uses stack as a memory model, so it's not aligned with bare metal machines, right? So no wonder it is slow, or at least it used to be slow, because it was actually 20 years ago when the first version of Hotspot just-in-time compiler was released for Java. I think it was Java 1.2. And hotspot has been around for the last 20 years, right? This means a lot of research, a lot of money poured into making it really high performance. And the thing is that, on the other hand, hotspot has been around for 20 years. I mean, it's written in C++. It's quite outdated. It has become a bit more unmaintainable. And that's what Oracle folks admit. They admit that hotspot is a wild beast, and it's very hard for them to develop against hotspot. So one thing about hotspot that is even more important is that hotspot is optimized for data center deployments, not for modern world, right? With data center deployments, I mean things like we have application server. That is a long-running process. We deploy application, we drop a WAR file, then it gets exploded, and so on and so forth. But it is a long-running process, and you don't care that much about the startup time, right? Because, well, it will warm up, and then it will be fast. And that's fine when you have a data center, when you do the traditional way of web applications, right? What if you do microservices? Is that what you want? Well, not really. With microservices, the thing that you really want is fast startup time. That's because you want to spin up instances of your microservices as fast as possible so that they can handle the incoming traffic. So that's my third controversy today. Java is not really cloud friendly. Do you agree? Who does agree that Java is not cloud friendly today? Okay, some people agree. Who doesn't agree? Even less people, okay. Well, you could argue that there are things like, for example, Spring Boot Cloud, and Netflix has built their whole stack using JVM, right? So they use mostly Java for their system, right? Well, I can counter it with one example. Do you run your JVM processes in Docker containers? Who does that? So you probably know that Java, the Java virtual machine, is Docker aware only since November 2017. And it can apply the limits, like CPU limit or memory limit, only since then. And before that, it ignored those settings, right? So then I've got another controversy. Java is not the best language in the whole world. Who would agree? Oh, you're attending a Java conference, right? Excuse me? Oh yeah, there is Kotlin, which is better. That's true. I mean, there is Kotlin. That's the part that I agree with. Okay, so again, it of course depends. That's the best answer that a senior developer can give, right? It depends. There are new JVM languages. Some of them aren't that new, actually. But we can see a trend that alternative JVM languages are gaining in popularity. And there is Kotlin, of course. There is Groovy. There is Scala. But what is more, actually, since there is not only JVM, right? There is Node.js. People use JavaScript for developing their web applications. There's Python, right? You can use Python and R for data science. So my point here is that it all depends on the problem that you want to solve. And the wise approach is to use the right tool for the job, right? And if you have complicated big system, you can come up with an idea of polyglot programming, right? Where you divide the problem into smaller pieces and use different languages for different solutions, right? Just to apply this basic rule that you want to write, you want to use the right tool for the job. And of course, this is very very doable on JVM because JVM has a basic interface for any language that is run on top of JVM. That's bytecode, right? So if it is bytecode, you can call it from any language that you want to do. So it's quite easy to do the in-process polyglot programming with JVM. And then we've got even APIs for running things like scripts, right? There was Bean Shell API up to Java 8, or I think it was Java 9. We've got Nashorn for running JavaScript, right? So programming, polyglot programming on JVM is, I would say it's easier than polyglot programming out of JVM. Why is it so? Because you've got two options. One option is that you can do inter-process polyglot programming. So you've got different processes talking to each other through Unix socket or through TCP/IP, and then you've got the problem that this is going to be really slow. For example, if you want to do some big data analysis and use Python for part of this analysis and then R for the other part, then you're screwed. Because the data that is processed will need to be transferred between the two processes, right? And then, well, you could argue that, well, let's do it in process. So let's keep the data locality, let's keep it in one process, and then you're screwed because you need to use C to stitch the two together. Would you like to stitch Python and R together? Raise your hands. Who would like to do that? I know, very wild side project. That could be really nice. There are people who, for example, are embedding R in Node.js. Why would they do that? Okay, so inter-process or intra-process, in-process polyglot programming outside of JVM, that's probably not really an option. And then you can come up with an idea that you want to implement your own language because there is no right tool for the job right now. And if you want to do that, then the usual approach is that the first thing that you need to do is to write a parser that will emit an abstract syntax tree and then use the AST interpreter, the abstract syntax tree interpreter, right? And this interpreter will be slow because, well, it's just walking through the data structure and invoking procedures based on the type of the node, right? And that's how Ruby used to work. So it might be an option actually. But people will complain that it is slow, and you will need to implement runtime for your language as well. Things like garbage collector, or threads, or maybe thread scheduler. So good luck with that. And people will complain that it is slow. So you will probably come up with an idea that you need a virtual machine, a bytecode format, and then your virtual machine will be a bytecode interpreter. Why would you want to do that? Because it's easier to do optimizations on bytecode than it is on AST3, right? And then people will still complain that it is slow, so we'll probably want to implement a just-in-time compiler. Who would like to implement a just-in-time compiler? Thought so, no one. I wouldn't. So there's fifth thing that you would probably need if you want to have proper language. You need to have a foreign functions interface so that you can integrate your language with C, right? For things like embedding your interpreter in C or C++ program, for things like writing some functions of your language in C or C++. And on Java, we've got Java native interface or Java native access, right? My point here is that it's a bit easier on JVM because, well, there are things that are granted. The bytecode format is already defined. You've got a bytecode interpreter and bytecode just-in-time compiler, so that's something that you don't need to care about. Parts of the runtime are also implemented for you, so you've got garbage collector and all that stuff. There's only one problem with that. The just-in-time compiler. It's something of a black box right now. With Java 8, let's say. You can sprinkle bytecodes on top of it, and it will spit out native code. But you probably will have no idea why this code is not performing as good as it should, right? That's, for example, what has happened at Twitter with Scala, right? So Scala, it uses Java bytecodes. It can compile to Java bytecode, but then it is slower than Java. And why is it so? Well, you could try to find someone who understands hotspot and could give you some details on how to improve the Scala compiler and so on. But the problem is hotspot is deep magic, right? And there isn't a lot of experience around to use for daily job, right? There is not many people that understand deeply how hotspot works and how to tweak it. My point here is JVM is an engineering wonder, right? There is no doubt about that, but it has its issues. And those are the reasons, I believe, that GraalVM is really needed today, right? Do you have any questions about this part? So this is the background that I wanted to show. Do you have any questions about that part? No questions. Okay. So let's move on to what is GraalVM. So GraalVM is actually a couple of things, and people, when they talk about GraalVM, they might mean different things. First of all, in its core, that's a just-in-time compiler. So it's pretty much something like Hotspot, but it's different from Hotspot because since Java 9, the Java virtual machine exposes a Java accessible API that is called JVM compiler interface. And GraalVM uses this interface to implement a just-in-time compiler in Java. So I think that's the most important difference between Hotspot and GraalVM. Hotspot is written in C++, and that's what Twitter people say. They don't teach proper C++ anymore. So that's why they actually decided to use GraalVM, because it's written in Java. They could contribute to its development as well, because they've got lots of Java expertise. So GraalVM, first of all, a JIT compiler written in Java, more maintainable, using more modern techniques. We'll take a look on those techniques in a moment. But GraalVM is also a language implementation framework on top of GraalVM, on top of this just-in-time compiler. And this framework is called Truffle. Have you heard about Truffle? Who has heard about Truffle? No one. Is anybody doing things like, I don't know, Python development, Node.js development? Something other than Java or JVM languages? So you might actually get interested in that because Truffle already provides implementations of Python, R, Node.js, and Ruby. Do we have any Ruby developers around? Do you use JRuby or? Okay. So, and of course you can use this framework for developing your own language. And the main point here is it's gonna be blazing fast. Why? We will see in a moment. And then there's third part. I think this one actually made a lot of buzz, most of the buzz around GraalVM. That's Substrate VM and native image tool. Have you heard about it? Who has heard about native image and running Java as a native code? Some people, okay. So the basic idea here is that we can have a simplified Java runtime that is called Substrate VM that contains things like garbage collector, thread scheduler, but it doesn't contain things like class loader or just-in-time compiler. And then we can use this runtime to deploy things like binary code, native code, that was produced by native image. This is bytecode translate ahead of time into binary code. So you can take a jar file and transform it into native executable. the same as you would do with a C program, right? Or you can take a jar file and compile a shared library out of it, like DLL on Windows or shared object, and just use it as a native code. Okay, so let's talk about GraalVM Deep Magic. So what are the techniques that are used to enable this cool stuff? Let's talk about GraalVM just-in-time compiler first. So the most cool technique that I think needs describing here is partial escape analysis. So who knows what escape analysis is? Okay, so please bear with me. I will try to briefly explain what it is. So when you develop a Java program and you create instances of objects, those instances use memory allocated on the heap, right? So JVM asks for memory from the operating system, and the operating system provides some contiguous area of memory, and then JVM uses it as a heap, right? But even though JVM has been optimized for allocating memory on the heap, it still takes some time, right? And then there is the other side of memory allocation. If you take some memory, you need to return it back, and that's why we have garbage collector in JVM, right? But running garbage collector on JVM, it's non-deterministic, so you might get things like 1 minute. Well, we used to get things like 1 minute pauses only for garbage collecting, and it takes time, and it takes it also takes some memory for just housekeeping. So what you can do, and that's compiler technique, you can try to look at your method, a single method, and see if the objects that are created inside this method leave the scope of this method. For example, if they are assigned to a global static variable, or if they are moved to some another thread, or maybe an object is returned from this method. If it returns from the method, or if it somehow leaves the context of this method, it is said to be escaping from the method, right? What can you do is, if you have an object that doesn't escape from the method, you don't need to allocate it on the heap. You don't need to have memory on the heap for that object, right? You can use the stack frame for that. And you can allocate it statically on the stack frame. And that's what hotspot does. So if an object doesn't escape from the method, it uses escape analysis for keeping it and avoiding all the hassle with memory management, right? The thing is that sometimes you can get different code paths, and in one code path, the object will not leave, it won't escape the method. In another one, it will do that. And then, in case of hotspot, basically this means that there is no escape analysis done, right? The object will need to be allocated on the heap because it might leave or it might escape from the method. GraalVM employs partial escape analysis, which means that it will analyze all the code paths, and in cases where the code path doesn't cause the object to escape from the method, it will use this technique of avoiding memory allocation. So it will actually allow for using the stack frame for object memory. And once the object is on the stack frame and not in the heap, you can do more things, because you can do something that is called scalar replacement. Scalar replacement means that instead of using a structure, which object is, right, in the memory layout, that's just a structure, a couple of fields, it means a contiguous area of memory, right? But instead of using a structure, you can use local variables and get rid of the object. And when you do that, you get even more data locality, because it means that instead of keeping one structure in the memory, you can keep a couple of variables in in the CPU registers. And you avoid fetching that from memory. You can keep it locally. So it means that it will be a couple of orders of magnitude faster, right? It can be 100 faster than just using memory. The other thing that you can do when you have object that doesn't leave the context of the method, you can do the lock elision. So you can get rid of locking. And GraalVM understands JVM locks. And it can get rid of many of those locks so that there is no overhead for gaining a lock and then giving it back. OK, so that's one cool thing about, I think that's the most coolest thing about GraalVM just-in-time compiler. Then let's talk about Truffle, the framework for implementing new languages. So what they did there, the basic technique that they use is partial evaluation and so-called Futamura projections. Have you heard about it? Who has heard about partial evaluation? OK. So that's an optimization technique. Let's say a program is actually a function that takes two kinds of input. Static input. That's something that we can precompile or do computation ahead of time. And then there's a dynamic part of the input. And the program takes care of transforming those two into output, right? On a very high level. And what you can do, and it's a common optimization technique that is used by pretty much every compiler, you can take the static part that doesn't change and precompute it, right? Like if you have, I don't know, in Java you have a string that is composed of multiple lines, and you use a plus operator for joining that. Of course, it will not be joined at the runtime. The compiler will stitch it to one string, right? So this is something that we could say is an application of partial evaluation. But the interesting thing, and that's something that Japanese researcher Futamura discovered, is that you can do the same thing with interpreter, right? So let's say that your program is written in an interpreted language, right? And you can treat this program as static data that is executed by the interpreter. So you can stitch the interpreted program and interpreter and just leave out the dynamic part, the user input. And then what you will do if you do the precomputation, right? If you add interpreted program and merge it with the interpreter, you will get faster execution. And that's what basically Truffle allows for. So on the code level, this means that when you develop an abstract syntax tree interpreter using Truffle, you can hint it with some annotations. It gives you some basic types for nodes of this AST tree. And as I mentioned before, this has already been done for languages like Python. So there's an implementation of Python that uses this technique. It is blazing fast. There's implementation of Ruby, Truffle Ruby, that's what it's called. It's faster than any other implementation of Ruby. So it's faster even than JRuby. Then there's Node.js implementation. So they actually took Node APIs, and you can run Node.js software on JVM. And the last one is R. This one is really faster than the regular R implementation. But there's one more question. What if we have, let's say we have Ruby, right? In case of Ruby, there's lots of C extensions to the language, right? So if you have a gem, Ruby gem, that's Ruby library, it can be written in Ruby, but usually if it's slow, it will be re-implemented in C. So what if you want to run C software on JVM. That's also possible because there is also an interpreter written in Truffle for low-level virtual machine bytecodes. So you can compile the C code into LLVM bitcodes, I'm sorry. And this is something that GraalVM will understand as well. And it will be really fast with that as well. OK. And then the native image tool, it basically uses one principle, the closed world principle. It means that there's no runtime definition of classes, of Java classes. And then it applies all the other techniques that I already mentioned, right? Why is it so? Because if you know what are the bytecodes that you're going to load at runtime, you can apply a lot of aggressive optimizations. And by doing that, you can do things like remove dead code, right? OK, who can tell me how much does it take to run simple Java world program, simple hello world on JVM? Anyone? How much? 0.7 seconds, something like that, right? Why is it so much? I mean, if I write it in C or even in shell, this will be much faster. Well, the problem here is that when I use Java, it needs to load all the JDK classes that are used. It needs to spin up all the subsystems, and only then it can execute system out println hello world, right? If you use native image generator tool, it will get rid of all that stuff because we don't allow loading classes at runtime. It all needs to be compiled into native code already, right? And that's the basic promise of native image, that you can have your Java code start up really quickly. And that's, I think, the coolest thing about native image, because this means that you can write microservices in Java, right? Well, you need to compile them into native code, but still, you get the same blazing fast startup time that you get with C or Go, right? So this, in my opinion, is a game changer for Java in cloud. OK. So let's answer one more question. Is it worth your time? And in my opinion, you need to take into account a couple of things. This is still in research, right? So Oracle folks are still doing research around it. The GraalVM first generally available version was released a couple of weeks ago. Who uses SDK man for managing Java? So if you use SDK man, you can download Graal as well. Then there are two versions of GraalVM, Community Edition and Enterprise Edition, right? And Enterprise Edition, it's Oracle licensed edition. So here be dragons, basically. And you can use Enterprise Edition for evaluation purposes, right? So you can just download it from graalvm.org and use it for evaluation or for development. The problem starts when you want to run to production with it. Then you need to start paying Oracle. And I don't know what are the prices, so don't ask me about that. The problem with CE and EE difference is that EE is much more powerful. So it applies more optimizations. It is really faster. Then, if you use native image tool, the EE version will provide you with debug information and profiling information. So it embeds dwarf into binaries. The CE version doesn't do that. But you can debug the JVM, right? And then just try compiling it to native and hope for the best that there is no bug in the native image tool. But unfortunately, they do happen. And then you need to debug it and let know Oracle what's happening there if you want to get it fixed. Then one more problem is that there is no official support from the most widely used JVM library or framework for web applications. Spring doesn't support GraalVM yet. They're working on it, yes? Yeah, there is a proof of concept. You need to do quite a bit of configuration to make it work. but it's not officially supported, right? So you need to think about it, weigh the pros and cons. I think that's a quite interesting project. It's really worth your time to see what's happening with GraalVM and what are the things that it enables. And how to get started? One thing is that you should go to graalvm.org and see the documentation there. It's really good documentation. Then you could Google for 10 things that you can do with GraalVM. That's by the project. That's a blog post by project lead by Chris Seaton, and it shows very nicely what can be done with GraalVM and how you can use it. For example, this is something that I didn't want to deep dive into, but you can also use GraalVM inside your database, inside Oracle database, for things like stored procedures. Do you do that? For stored procedures? Okay, no one. And if you really want to continue with Spring model, there's one nice framework from the United States, Micronaut. They started last year, and they're using a very similar very similar model to Spring Boot, but it's all static. Right? They don't do things like runtime annotation analysis. Instead, they're using annotation processing tool from JDK for generating all the metadata that is required for doing things like inversion of control. Right? So I would really recommend looking at this one as well because it has native image baked in, native image support baked in, right? It also has things like Docker support, so you create a new project with their tool, and you've got all batteries included. Okay, and now it's time for questions. Do you have any question? Yes, please. I'll come to hear your question.
Does GraalVM plan implementation for Windows?
Yes, so there will be official implementation of GraalVM on Windows. There you can download evaluation right now from Oracle side, but they do plan to support Windows at some point.
At some point means?
In the near future.
Okay, thanks.
Okay.
Thank you for your presentation. The question I have is, if I will do the native image, will I have the garbage collection running there?
Yes, so things like thread scheduling or garbage collector are included in the Substrate VM. So this is a simplified Java runtime. But the basic thing is that Substrate VM doesn't allow defining classes at runtime. Right? So that's the only or the most important constraint that you have with Substrate VM. And please come after the presentation. If you ask questions, please come to the table. And
I have a question. How can you unlock a GraalVM compiler in OpenJDK?
Excuse me?
Can you unlock GraalVM compiler from OpenJDK?
So there are a couple of things you can do. One thing is that, first of all, you can download the GraalVM distribution that is based on JDK 8, right? And if you don't want to run on JDK 8, you can download the sources of the community edition, compile it, and then use the command line options for enabling it. Okay, one more question.
Have you tried tuning Graal compiler to achieve a less CPU usage?
Well, I haven't used it in production yet. But my default SDK is actually GraalVM right now based on Java 8 SDK. So, okay.
I actually have two questions. One of them, is there any time horizon for releasing the productional version? And the other one is, have you tried GraalVM with any kind of function as a service framework? I don't know, AWS Lambda, FN, or something like that?
Okay, so there is a production-ready version already released. That's GraalVM 19.0 that has been released like, I don't know, 6 weeks ago or something like that. It still has some issues right? There are open issues on GitHub, but they're working on it. But it's generally available version. And then using the, you mean the serverless solutions, right? I know that people are doing research in that direction as well. I haven't tried it myself, but it's perfectly doable. So you can develop a function in Java and then compile it into a native image. You probably would need some kind of stitching based on the cloud that you want to use, because at least I think at least in AWS Lambda there is some additional dance that you need to do. But that's what I heard. I haven't tried it myself.
I have a question slightly related to this one as well, because you mentioned the hotspot at the beginning.
Yep.
And that it's powerful when it's like, fully up and
Yeah, it needs
preheated
warm up.
and, yeah, warmed up and stuff. But do you really have any benchmark comparing this kind of warmed up hotspot versus
Oh yeah,
cold?
yeah. There's quite a lot of benchmarking done by Oracle for that. And so if you go to graalvm.org, they will show you what are the differences. The baseline is that GraalVM can be twice as fast as hotspot.
Even when hotspot is already warmed
Yes,
up?
for pre-warmed hotspot.
Okay, thanks.
Yep, and then there's another question.
Have you tried to run in GraalVM existing code, and what are the main drawbacks?
Well, if you're using GraalVM just-in-time compiler, there basically is no drawbacks for that, because it's still Java, right? The drawback is if you want to run using native image, and you want to do ahead-of-time compilation, because basically you cannot do anything like a plugins-based system, right? I work on Jira. My day work is working with Jira. Jira is plugins-based system, right? So there is no way we could ship precompiled Jira, because we don't know what the customer is what are the plugins that the customer needs to do. So if they want to do that, they would need to basically they would need to know what is the set of plugins that they're going to use, what is the total Java code that or Java bytecodes, all the jars, right? Then they would need to gather that data and feed it into the native image tool, and that's becoming better and better, but still the native image tool still needs some hints about what is happening in your Java code, right? If you use something like class for name, it can do static analysis for that. So it's actually not class for name, because it's going to be loaded at ahead of time, at native image time, at native image generation time, right? In the runtime, there will be no new class being defined, right?
Okay, but did you run Jira, for instance, in GraalVM, and did you have any?
Not yet. That's my big project.
Because some time ago, when I tried to run, for instance, Grail's application on different VM, like on IBM VM, I discovered that it is not compatible, fully compatible, because of some things, some tweaks inside.
Okay.
And I'm wondering if there is something that can be hard to switch. I mean, if there is some incompatibilities or something like that.
Not that I'm aware of.
So
I mean,
you can just take
yes.
existing code, run it, and it should be fine.
Yes, and it should be faster. That's the basic premise.
Okay, cool.
Okay, there's one more question there. What's the time? Oh.
Okay, hello, thank you for the presentation. I have a question about profiling of the application. Is there a standard interface for JProfiler or APM softwares?
Again, that depends if you want to use just-in-time compiler or ahead-of-time compiler. So if you use just-in-time compiler, it's actually even better because you can use JVisual that comes with the JDK, the GraalVM JDK. But if you're using implementations of languages like Python or Truffle Ruby, the JVisual VM will understand Truffle. So it will not show you only Java objects. It will show you Java's heap, and then it will be able to show you the Ruby heap.
Nice.
So it's really nice.
Have you tested it?
Excuse me?
Have you used it?
I just played with it. Okay. So that's a disclaimer that I forgot to put in the beginning. This is only a result of me playing with GraalVM, not doing any real world stuff with it. But I think it's worth spreading the knowledge about it, because in my opinion, it will change Java world a lot. Okay. Okay, so if you, one more question, right?
Do you know any like future of community edition, or maybe possibility of open source, competition in this area?
Well, not really. I mean, people are contributing outside of Oracle to community edition, and you need to sign the contributors agreement and so on, but people are doing that, and that's it. So, but the main driver, of course, is Oracle. Actually, it's a research project that is run by Oracle and universities, so there is a lot of academic research behind it as well.
So you don't see any, any possibility of open GraalVM or something like that?
Well, the community edition is open source.
Yeah, but it's lagging in features, right? So
no, I'm not saying it's inefficient. I'm saying it's not that efficient as Enterprise edition, but it's still more efficient than Hotspot. Okay, so if you asked a question, one more question? Okay, thank you very much.